6th grade lesson 5.6. This is finding the whole from a percent. And the book, as usual, will give us a couple of options on how to do it because all of our brains work differently. So it's always helpful for us to kind of see what's happening and then we find the path for the way that works best for our brain. I will actually show one more way on top of it. The book doesn't show this to you yet, so this is why it's not in there, but they will later. The reason they don't is they haven't yet taught you one-step equations. But I think a lot of your brains that I work with you guys on are perfectly ready for understanding the basics of one-step equations. And it's my favorite way to handle the finding the whole from a percent. So I'll show it to you. And if it confuses you, then you just fast forward right through it. But if you want to see if that's something that works best for your brain, have a look and you can decide if that's something you want to use as well. I'm just giving you that option. So let's first talk about percents. Remember that percent is a ratio with 100. So 20% is 20% or 20 out of 100. I think by now you guys are all very comfortable with that. And the only thing we're pointing out here is that 20 is the part of the whole 100. So get familiar with part compared to the whole, and we will use equivalent ratios to find out parts of the whole in terms of percent. So let's go ahead and have a look at what I'm trying to say there. So at the very first part, they talk about percent being equivalent to the ratio of a part to a whole, which is what I was just mentioning. And they say, suppose there are 20 marbles in a bag, 20 marbles in a bag, 5 of them are blue. 1, 2, 3, 4, 5 of them are blue. The whole is the total amount are in the bag, and the part that are blue is 5. So if we want a ratio of blue to all, we would write that as a ratio of 5 to 20, right? And if I wanted to know what percent of the bag is blue, well, remember, percent is out of 100, so I need to do a little math magic on here and make that 100 so that I can see what that is as a percent, because percent out of 100. So what would I multiply 20 by in order to make him become 100? I'd multiply him by 5. And if I do that to the denominator, I must do that to the numerator as well. And that gives me 25%, 25 out of 100, which is 25%. So understanding that relationship between the ratios and what percent means and part of a whole will help you get through this. This was nice and easy because 20 is can be multiplied by something to land exactly on 100. That always doesn't happen. So that's why we have other tools to help us through it. So let's look at the first tool they talk to us about. So the first tool they're going to introduce to us is this double number line. And here they have this picture of a teenager texting on her phone. What? A teenager texting on a phone? Does that ever happen? How abnormal, right? I'm just kidding. You know that's very normal. It's a teenager in the wild. Let's read the expression, the problem. Emily has sent 28 text messages so far this week. That is 20% of the total number of text messages she is allowed in 1 week. What is the total number of text messages Emily can send in 1 week? So clearly not an unlimited plan. She can send a certain amount each week. She has sent 28, which is 20% of what she's allowed to send. 28 messages, 20% of what she's allowed to send. Okay, so we can take this information and we could call this our drawing, right? We can take this information. The whole is the total number of messages Emily can send. We don't know that number yet. That's what we're trying to find out. The part is the number of messages Emily has sent so far. We learned that she has sent 28. The double number line shows that 20% represents 28 messages. Here is 20% representing 28 messages. They dragged out the number line to 100% because we're talking about percents. 100% is the whole thing. So what would I do to 20% to get it to become 100, or to 20 to get it to become 100%? I would multiply by 5, right? 20 times 5 gives me 100. If equivalent, again, it's all that equivalency we're always doing. If we do that to this, we must do that to that. Times 5 will give us 140. And so 100% or all of the amount of text that she's allowed to send in a week is 140. 28 is 20% of 140. So Emily can send 140 messages in 1 week. So one option is just to use the number line, find out what percent and what is the partial amount as a ratio, and then push them through till you have 100% and stay equivalent as you go. That's one way that you can find that information. Here's another way, and they're going to use equivalent ratios, and this is going towards the third way that I will be showing some of you. Is kind of the same idea. So the first thing they're going to do, so we're still talking about Emily's 28 messages being 20%. Write the relationship among the percent, part, and the whole. The percent is 20% that she's used so far. The part is 28 messages. And the whole amount that she's allowed to use is unknown, or it was unknown until our last slide. We know what the answer will come out, but just humor me on this. They want us to mark the part and the whole. We don't know the whole. If you don't mind, I'll just use a variable x for that. It's unknown right now. Well, we're pretending it's unknown right now. And the part is 28. Now to compare those ratios, we're going to write the percent as a ratio to 20%. Again, we still don't know that unknown part. That's what they want us to find out, right? So on this method that they're showing us, they say, you know what, go ahead and simplify this ratio so that it's easier to do. Let's get this down to a 1 unit. 20 divided by 20 will give us 1. We'll have to do whatever we do to numerator, we must do to denominator to keep things equivalent. So 100 divided by 20 is going to be 5. Okay, now that I have this to here, I can ignore that. And what would I put times 1 to get to 28? I would multiply it by 28. So I'm going to do the same to the denominator, 5 times 28, and that's going to give me 140. So 28 over 140 equals 28 over 140. The numerator should be 28, the part, right? And 28 is 20% of 140. Emily can send 140 messages. All right, the third way kind of matches everything to this point here. So let me just kind of refresh your memory on something I've mentioned before with equivalent fractions. 1/2 is the same as 2/4. If I have 1/2 of a pizza, that is the same as if I had 2/4 of a pizza. Those are in fact equal, same amount of pizza, right? Okay. To prove that something is, if it says that these ratios are in fact equivalent to each other, and it does say that because it put the equal sign there, I can prove it by multiplying these crosses. 2 times 2 equals 4, and 1 times 4 equals 4. And those are exactly the same number. If your ratios are in fact equivalent, then when you multiply their crosses, they will equal each other every time. Every time. So I can use that to my advantage if I come back over here to step 2. I had 20 out of 100, 20% of the part 28 compared to the unknown whole. I'm going to rewrite that over here. All right. So now I know that if I multiply these crosses, then they will equal each other. I'm going to use that to my advantage, okay? I'm going to do 100 times 28. And that will equal 20 times x. So we calculate that. 100 times 28 is going to be 2,800 or 2,800. 20 times x is 20x. And now what I'm going to do is I'm going to try and isolate this x variable. That's the game, is isolate the variable. And I do that by doing the opposite, an inverse operation. This is being multiplied by 20. So what is the opposite of multiply by 20 to cancel it out? You're right, it's divide by 20. So I would divide by 20, and I'm allowed to do that because, again, I will be fair to both sides of the equation. that allows me to do that. 20 divided by 20 is 1. That left me with x, or 1x, isolated. Then I just have to do 2,800 divided by 20, and that will bring me to 140. Ta-da! So there's another option. This is the part I was talking about that you haven't really learned yet. You'll get into that in a couple of chapters. Isolating the variable, getting it by itself on his own side of the equal sign. Think of the equal sign like an ocean. We want him alone. We do the opposite operation. This was multiply by 20, so we do the opposite. We divide by 20, and as long as we do the same thing to the other side of the equation, then we have kept our equation balanced. So that is another tool that you can put in your toolbox to use with this as well, if that makes sense to you. If not, stick with these, whatever the other ones make sense to you. And I think one more example will help solidify this for you. The example is they want to know what that 24 is 5% of what number? 24 is the partial number. There's a whole amount that we're looking for. So we always have to kind of think in terms of part and whole, and the percent is always part of the whole 100%. So the percent is 5%, so I'm going to put 5% here. And the part is 24, and the whole amount is what is unknown. So we're looking for 5% of 24 out of, we don't know the whole amount, we'll just call them x for right now. We'll write the percent as a ratio, 5%, and it's going to equal 24 out of, we don't know how much. I'm going to put an arrow here to do that other way that I showed you for those who want to see it in a moment, but we're going to continue on the way the book shows us first. So they have this 5 out of 100, and we really want to turn that into a 1 unit one. So to break it down, so we're going to take that 5 and divide it by 5 to get 1. And if we divide this by 5, we're going to need to divide that by 5, and that's going to give us 100 divided by 5, which is 20. Okay, we still don't know that other amount. But we do know that 20 times 5 will bring us to 100. I'm sorry, no, I take it back. We do know that, we don't know what this is. We do know that 1 times 24 will bring us to 24. And if we did times 24 to the top, we must do times 24 to the denominator on the bottom. And so if we do 20 times 24, we're going to get 480. So 24 over 480 is going to equal 24 over 480. 24 is 5% of 480. So that's one way to do it, is to just break this 5 out of 100 down to 1 unit so that you can see what needs to be done from there. That made perfect sense to you. Stick with it if it does. I'm going to go back a few steps back to this one and use that multiplying the crosses trick that I showed you, because maybe that was hazy, and maybe one more time through might make it make sense. And if you like using it that way, then you use it that way. Let me go ahead and rewrite it just so we have it in our brains. We had 5 out of 100 equals 24 over x. And if those two ratios in fact equal, then when I multiply the crosses, 100 times 24, they will equal each other. And 5 times x will all equal each other. I multiply those together, I'm going to get 2400 on this side and 5x on that side. And now I'm playing that game, thinking of this equal sign as like this ocean, and I want x isolated on his own side of the ocean, and he's hanging out with this 5. He's being multiplied by 5. Undo that. The inverse or the opposite operation of multiply by 5 is to divide by 5. And if I'm going to do that to that side of the equation, I must do that to this side of the equation as well. 5 divided by 5 is 1. That gives me 1x. So now he's isolated. And I just need to find 2400 divided by 5, which is going to be, you guessed it, 480. So there's just another way you can do that. Again, this is something that you'll learn as we go on, but if it's that starting to make sense and you want to practice it a little bit, feel free to use this tool for this if you wish. If not, use the way they're showing you. Just bring it down to 1 unit and then use that to manipulate to bring this up to the equivalent amount. So lots of tools thrown your way. Give it some practice. Rewind if you need to review those a little bit to make sense of them a little bit more, or ask me if you're really, really stuck. Good luck with this. I think you will do very well.